And we're live. Okay. Welcome, everybody. Tonight is the 2nd of March in 2021, which seems in some ways like 2020 just keeping going on, but here we are. This is the Dallas Personal Robotics Group. We meet every Tuesday night or Wednesday afternoon if you're around the other side of the world, and then every second Saturday of the month. And we'll do the usual tonight. We'll just wander around the table and talk about the robotics projects, mostly robotics related projects that we're working on for fun or whatever. Raise any questions and put them to the team, and share our tips and tricks and fun stories. My name is Carl Watt. I'm the current president of DPRG, and well, anyhow, with that, I'll just ask who has something that they'd like to lead us off with tonight. Donna wins the hand raising contest. All yours.
I don't have to go first, but I do have something to share. So, well, thanks for taking me first.
Yeah.
So I've been doing some research and planning and figuring out what I want to do where regarding the club project for virtual communications via the internet for either for a telepresence robot or for any kind of virtual attendee to be able to hopefully enter or participate in a DPRG contest or event in the future. So I've been doing some brainstorming, some learning, because this whole internet communications and HTTP and PHP and all that is really quite new to me. And so this has been a great learning opportunity to start digging into that stuff. So aside from what our little mini committee who are starting to work on this platform, one of the things that we're looking at is the idea about utilizing AWS cloud services to facilitate internet communication. And so what I decided to do was before launching into that whole ball of wax for setting up an account, for working through developing a robotics example utilizing those services, I decided to backtrack a bit because I have a lot of some website and systems and services background specific to my business ventures that I'm currently working on and providing some services for. So, and I've got quite a lot of WordPress experience. So what I decided to do was to tackle possibly this virtual, or at least on the web server side, looking at this not necessarily from the AWS side, but from some different angles. So what I decided to do was go back to some basics and look at the idea of share, some web server hosting type plans for the idea of, in a lot of respects, what's potentially bad with the AWS cloud services is the idea that you don't have a fixed, sure, you can, max out per month of how much the club is spending to utilize those services, but you're not on a fixed plan. And so what I decided to do was to specifically, just to cut to the chase, I decided to look at some web server hosting services. The main one that I found that I really liked well is a company called InMotionHosting.com, and likely the idea about shared hosting is probably the way to go, for the idea about just having a single site that would be on the DPRG server side. And the idea is that the user can set up a cPanel. and they can decide whether or not they want to install WordPress or other plugin and services to develop their website. What I liked about in motion hosting is that with the cPanel, is that it's got a lot of cool features with it that could easily help with this project. Specifically, there's a SSH communication plugin. It's real easy. I'm sure for a lot of you that are on this call, all this is old hat because a lot of people already know about a lot about website development and all this. But for me, it was kind of a deep dive adventure. So anyway, and then it's real easy to go in and create or upload existing sites or create sites literally from scratch or from other plugins, etc., that you can download and then install. And then you can easily, on the fly, while you're within your cPanel instance, you can easily update PHP files, HTML files. You can do a lot of, in our case, robotic communication into that server, into that website that you're creating and managing. And you can do a lot of on the fly, more quick turn testing. And so, and what I don't know this for sure, but I suspect that with the popularity of WordPress, that with all the various types of plugins that are available, either third party for paid or for free, then more than likely there are some cool that we could possibly use Internet of Things type plugins that might provide the same types of services that the
Oh no. Oh no, Donna, we lost you. Internet broke. Who pulled? Oh, there you
it
are.
was
You're back.
Maybe
it was
are
my
you are you streaming? Are you hosting yourself on InMotion right now? Maybe that.
no, but I haven't gotten that. I just finished kind of this afternoon of researching what I'm communicating about right now. But more than likely, for the idea about a test bed while I'm developing my own internet ready or internet capable robot that I can virtually communicate with. I'm suspecting that something like this might be because it's relatively cheap. With InMotion, you can spend as little as $6 a month on a plan that can give you, in their case, up to 2 websites and basically infinite number of subdomains off of each of those sites. And so there's lots of room for experimentation, customization. That's one of the things I like about WordPress is all the cool custom things that you can do. So anyway, the long and the short of it is that I plan on, for my own, the idea about having a test website that I myself can develop some PHP scripts for the idea about giving real-time feedback about what my internet connected robot is doing, and maybe sending back and forth messages as well via internet communication. I thought that for myself that might be at least a fun starter project to get going on learning more about PHP and internet communications and working with the Raspberry Pi or some other Wi-Fi enabled microcontroller. And so I'm not necessarily suggesting that we, as the subgroup, necessarily scrap the AWS cloud solution. I'm not suggesting that because I don't know what WordPress might offer for plugins in the Internet of Things space. But I thought that was, and I can provide separately here in chat some of the specific reference websites that I found today that provide some great information about types of web servers that are popular, the type, and then intelligently of how to choose. You know, if you choose on shared hosting or a dedicated hosting server. Anyway, all those kinds of things. And so I just wanted to share what I've researched so far on that project.
So I'm excited to hear that you are making progress on that. I'll be
Yeah.
interested to see how you implement some of those things, which choices you make.
Right. So
Donna,
anyway,
for what it's
uh-huh.
worth,
Yeah.
I actually have some experience with InMotion on WordPress, or I mean, the other way around. Our company, or my company, Telecom, our website has been hosted on InMotion, and it's a WordPress site for the last several years.
Mm-hmm.
And my colleagues set it up, but I've peeled away the layers of the onions and dug down into do various things with WordPress for SEO, and then also InMotion, to keep to understand the traffic and make sure that we have appropriate resources on the tool.
Mm-hmm. Mm-hmm.
And
Right.
then my colleague would handle the SSH certificates and all the other stuff.
Mm-hmm.
But my question for you is, are you thinking, because I find the idea of WordPress interesting, because I agree it can make for a pretty capable builder for a web page kind of UI.
Mm-hmm.
But I would see it more as the client side UI versus the kind of like a back end relay or processing. Is that how you were thinking of it? Or
Okay. So what I was thinking was the idea about the wide variety nature of plugins that are out there that are WordPress compatible, and that the majority, well, I mean, I know that there's a lot more in the world than WordPress as far as a tool that does what it does. For the minute, I can't think of some of the other tools I've seen, but the thing is that WordPress is so prevalent out there, and what I was thinking about is the idea of, just like with anything in software, there's all these different layers, and the idea is that if we could find plugins, WordPress compatible plugins that would provide, and maybe this isn't even relevant for this problem. Maybe if we set up a web page, regardless of what kind of tool that we enable or end up going with for this project, if we have the right PHP command set and all that, maybe everything, and then we set up both sides API to communicate correctly. Maybe the idea about WordPress or not isn't even an issue. But what I was thinking about was the idea of all the various either paid or free WordPress plugins that are out there, and the prevalence of the Internet of Things movement. More than likely, there's some overlap there as far as being able to utilize all that onto a website that can be custom.
Donna, can I interject a little bit here?
Well, of course, yeah.
I'm assuming that you guys have a plan to kind of do some custom plugins or do custom development on this, right?
Mm-hmm. Yeah.
Then one of the things, this kind of gets back to a conversation that the groups probably been listening to between David Anderson and myself, because David's been talking about, writing STM32 and C++ code, and I had made a choice early on to write my OS for my robots in Python. And so it was kind of this C++ versus Python, Raspberry Pi versus microcontroller. And it came down to, in a lot of it, the aesthetics or the choices that you make when you go into these kinds of projects. And so what had occurred to me on this is that I use WordPress and I really like it. That's how I do my blogging. But if you're going to do this, one of the things you'll have to deal with is that PHP as a language is not really used by anybody anymore except WordPress, and it's just legacy. And so what I'd recommend is because you're really looking for more of a web framework, is to think about the kinds of people who actually will be doing the development and working within this project, and what possible languages, the programming languages, they may want to use, because it probably won't, like, I wouldn't get involved in a PHP project simply because I haven't done PHP programming in over, I think, 15 years. And it's not an aesthetically pleasing language for a lot of people because it's very old school. So on the other hand, if you had a bunch of people or even a few people who were committed to the project who were, let's say, C++ or Python or JavaScript programmers, you might want to find a framework that used one of those languages of somebody in the project. And then the plugins are easy to write. Like I'm on, for example, I've for years been on the JSP wiki project because it's a Java project. And I wrote a lot of the interior stuff like the event handling for JSP Wiki because it's in Java. If it had been in a different language, let's say Python, like it was called Python Wiki or whatever, I probably at the time wouldn't have been involved because I didn't know Python. So point is that you probably want to find out which language those plugins could or would be written in, and then find a framework that's in that language. That's enough said anyway.
Oh no, good points. Good points. Anyway, so that's where I'm at with that. I want to, like I say, I want to utilize this knowledge, not necessarily for my contributions necessarily to this platform project, but I want to have a starter framework to do some testing of what I'm developing for the robot and the Wi-Fi communication framework. So that's the reason why I delved in that direction.
You mentioned as one of the motivations, the price tag, right? You said something, I think I heard, what, $6 a month?
Correct. Right.
Okay.
Right. Yeah. And there are other service providers that are cheaper, like Bluehost. They offer a shared hosting plan at $3 a month. But so.
Yeah. But just to compare that to some of the Amazon stuff, so my bill for last month, and it was an unusual month because I think I had my virtual machine running almost continuously, which I usually don't. And I usually just pay for the storage. So my storage, which I have a fixed amount of, it always comes to $3 a month, basically, just to maintain that storage. So I don't have to let it start from scratch. And then if I run a tiny virtual machine, and again, I think it was on for most of February, that came to another $3 to kind of have that virtual machine up and running. And maybe it was on 80% of the time. I don't know. I had to check. So I guess my point is, so you don't necessarily, I know you mentioned, it's not sort of a fixed price kind of setup at places like Amazon and Azure, but in a way it is. I mean, when you have a certain amount of storage and when you provision a certain caliber virtual machine, you know exactly how much it's going to cost you. There's no variable there. Again, I have to double check the amount of network traffic you hit and so on. I mean, you're talking sort of fractions of a fraction of a penny, so that usually doesn't accumulate much, at least not for my use cases. I'd have to look at that more closely. That's kind of where maybe the variable is, again, but just for the bare compute and storage sort of consumption, that is, I look at that as a fixed price, with Amazon as well. I just wanted to point that out.
Yeah, good. Yeah, good stats there.
Yeah, I mean, in some sense, you get less because you just get at least in my case, I get a bare bones virtual machine, and you get all these other services that, again, I don't know the pricing structure for everything that Amazon has. So in a sense, you get less for roughly the same amount compared to a web hosting setup. But then any web hosting setup is geared towards exactly one use case: hosting a website. Right? That's what it does, and it does it very well, and it gives you those bells and whistles that you need for that use case. There's things you're gonna get for the $6 that you don't get on Amazon. And so, but then you're boxed in, you're on a platform that's optimized for web hosting. So that would be my concern, right? It's optimized for that, and it's going to do that very well. But is it going to do other things well? That I have some doubts there.
Right. Right.
And,
Mhm.
and I can assure you that $6 plan, because I think we're on a higher plan now for our site, but even on the higher plans per month, it's still a shared environment, and we absolutely we get hit when we bump into the limit pretty easily sometimes, or we used to, and we had to buy it up a lot to get past that, and we still hit. I think we still feel the effects of the shared environment, adding delays, just randomly adding delays here and there.
Mhm. Right.
Because it's not I think it's I don't think it's one of these environments where it's like got a quality of service guarantee. As
Right.
I think you can actually pay for QoS levels in places like AWS and Azure. So you can be assured of certain response times and throughputs and things.
Mhm.
The other thing, I mean, again, so it's a platform. I mean, there's potentially all the building blocks potentially there, all these plugins that you mentioned. But I guess what's not clear to me, I guess that's part of what you're trying to research, right? How would I understand how the communication would work between my web browser and what's being hosted, right, on InMotion? That much is clear. But I mean, that's all interaction through standard web kind of stuff with plugins provided, let's say by WordPress. But then how does that WordPress environment communicate with the robot? How would that work? I mean, do you have any thoughts on that, or that's just part of what
I don't
you
yet.
want to research?
I haven't gotten that far.
Okay.
So
I was hoping that, and that's why I've been concentrating on the idea of what the various web WordPress plugins, the functions, the features that those might be able to provide. That I was thinking that would be the viable bridge between my robot communications up to the web.
I
That's
was thinking that was what you were thinking, and I was anxious to see what you found on that.
and I haven't gotten that far, Doug. I don't
Right.
know what the answers. I don't know what the answers. I'm just
Tomorrow's another day.
starting because I don't know that much about these technologies yet, and so I have to start somewhere. And
Exactly. You're having the interest of learning on it, so that's a
that's
great.
right. Yeah.
So getting back to the basic conversation that you started here is, and since Chris is here, he's on like plan 1 and you're on plan 2. There's 2 basic ways I see the robot being controlled via the internet. There's direct control, which is what the AWS that Chris was investigating does, where you're on a browser, you've got a joystick, and you're pretty much with low latency moving that robot around. And then there's some server control, which is what you were talking about, Donna, where you send a command from your client to the server and the robot asks the server, what's my next command? So that's what your plugins are going to provide. And,
Okay.
and to me, that's the 2 types of ways that we can control robots. And I'm like you, been focused more on the server side because that's what I know. But Chris had a very interesting presentation 2 weeks ago, I think it was now, on the AWS plan, which was more of a direct control. And I'm trying to segue into him saying, oh, look, I looked at part 2. Here's what I got to tell you.
Right. Right. Yeah. Right.
Put him on the spot.
Right.
No, it's fine. I can go next. No, I'll have to disappoint you a little bit though, because I didn't pursue part 2, and I read your meeting minutes, Carl, there. I was kind of hoping someone else would look at part 2. What I've instead done is explored another avenue, which
That's
I
good.
kind of talked about a little bit and demoed parts of it. You know, in fact, I mean, maybe that was last week. I don't recall, but either in an email or in the meeting, I said, "Oh, I found this other thing that will stream
Yeah.
video into a browser." Okay,
Right.
it does that and only that. Okay, so it's the building block. And then I mentioned and demoed previously that Pololu provided remote control web page. Okay, so I think what I talked about last time is, and what even others have mentioned, okay, well, wouldn't it be cool if those two were on the same web page, right? And so what I've done is I've just kind of I've hacked things together. I've taken the stuff that Pololu provided, right, for the thumb kind of touchpad remote control, and I've merged that with what I got from somewhere else, which will stream the video into a little thing on the browser. I'll show what that looks like in a second, and what some of the takeaways from that. But in terms of comparing sort of technologies, again, the avenue there is, all right. So on the user interface side, it's all standard web building blocks, JavaScript, HTML, and usual stuff. Uses some WebSocket technology, and I'm not an expert in web technology, so I just barely managed to hack this together. And then on the back end, it's mostly Python running on the Raspberry Pi. And again, for this to work over the internet, as I've kind of demoed differently previously, is you need a man in the middle there to connect the two together, because I don't want to expose my Pi to everybody on the planet directly through my home router. So again, I'm going kind of through and establishing kind of a tunnel through my virtual machine on Amazon, but that's just kind of a way of getting things all connected up that doesn't necessarily have to be permanent. But let me just show that while I'm talking. That makes things a little easier to understand. So let me go here. Let's see. Screen 2. Let's see. Okay. If you see this on the right side of my screen is my VNC window into my Raspberry Pi. I kind of mentioned that last time. I find that sometimes convenient to use VNC in the GUI, even if all I'm doing is running terminals. But so I'm in the Pi, SSHing into the Pi essentially in a fancy way. And from there, I did my, if I stop this, I hope it doesn't mess me up. From there, I have, okay, I've gotten into my Amazon machine. Okay, so this is again, I don't know how well you can see this, but I'm doing SSH with a bunch of cryptic options here that basically tell SSH client and server to do some port forwarding. But at the end of the day, what I'm doing is I'm SSHing into my Amazon virtual machine. Okay, but with parameters so that certain ports on that virtual machine, if you connect to port 8080 and 8081 on the virtual machine, you're going to wind up on my Raspberry Pi. That's the end result. Okay, and that's really what matters here. So I restarted that. Okay, so now I'm this SSH prompt now is my Amazon virtual machine. Okay, and I just got to run something there so it keeps me logged in. So now on the Raspberry Pi end, in another window here, again, this Pi camera H.264 web streaming repository is what I found. And as I said, hacked a few things together. So kicking this, I kicked this off. This is now again on the Pi, running a bunch of Python, and not a bunch, it's actually not all that much. Running some Python code, combination of stuff I got from Pololu, and merged together with stuff that came with this web streaming demo. So it's sitting there now and exposing a web server on port 8080 and exposing a WebSocket server on port 8081. And I don't know why it's not all on the same port. I don't know if it can be done. I suspect it can, but this is just how this particular demo works. Again, all these web technologies, I know enough to read it, to modify things, but that's about it. I'm not an expert in there, so it's mostly a black box to me. I just know enough to sort of, put two different building blocks together and make them sort of work. So my Pi is sitting there now with a web server, and again, similar to what I've shown previously, but so now I connected this locally. Okay, you can see here my 192.168.214, and here's the address 8080. That's now locally on my Pi, showing the video. Again, I've shown the video last time with previously, a couple of weeks ago, with very, very low latency on the local LAN. So this is nothing new. The latency here is a tiny amount, a little bit more latency here than what I've demoed previously, but obviously this is immensely more useful than having to use some M-player application. So this is now starting to be actually useful. Again, slight amount of latency, but not terrible. And so the top half basically came from this Pi camera demo. The bottom half comes from Pololu. And like I said, I just kind of copy and pasted things around and tweak things until they work. And so now I have this remote controllability, and I can notice, okay, so you can kind of see now the web server on the right. You can see the moment I have this page open, it's constantly asking for status, all right, get/status.json. So that request comes from this client, and the Python kind of answers that request. And if I move around here, you can see a flurry of kind of motor commands, zipping by here. Motors slash, left motor speed, comma, right motor speed is kind of the syntax here. But what I wanted to illustrate will become clearer in a second when I compare this to the going over the internet. If I move my finger here, or in this case, my mouse, because it's not a touch screen, you can see a lot of motor commands zipping by here, which kind of shows you there's not a lot of latency in the video, and there's not a lot of latency in kind of the command, sending the commands over and getting the response back. Okay, now I'm going to do the same thing going over the internet, and I'll post this into the chat, but only one person at a time can be connected here. It's not going to work properly otherwise. Mainly the interaction with the robot. So now, again, you won't really have a good appreciation for whether there is a lot of latency or not. The latency on the video side is obviously slightly higher. Now everything is going out to my Amazon machine and coming back, right? So this is going over the internet. Definitely, latency is a bit noticeable now, but not terrible. What is a lot more noticeable though is, and it becomes clear once I start moving my mouse around here in the remote control pad, is actually, I'm gonna have to refresh here. It had a little hiccup because I think something timed out, which is okay. Now it's okay. Now you see the status coming in, the status requests. Okay, that wasn't happening for some reason. Something had timed out, and it's a little fragile. But my point is, so when I start moving my mouse around here as fast as I can, you don't really see the same flurry of motor commands zipping by, and I'm not sure that's fully obvious, but it's maybe a third of the messages, and that just kind of reflects a little bit of the overhead in getting the command sent out and the response back. Because what's happening is, what I wasn't able to get to work properly, every one of these requests here, when it's asking for status for things like battery, or every time it sends a motor command, right now that HTTP connection is not being kept alive. It's every time it's a new connection, get me the status. Okay, I'm done. We're done. New connection, right? So there's this concept called keep alive in web servers, and that's not functioning properly here in my hack together thing. And so that's why there's actually a noticeable difference because of that when I try to interactively control it and put it down on the ground, which successfully too. Again, the video is
Chris,
not terrible in its latency, but because there's definitely a noticeable delay in the motor commands getting issued, and so it's still usable, to be honest, but there is actually room for improvement there to make this even more usable. And I'm happy about this because this is the reason I went down this path and wanted to get this to work, because this is something I can use on my local network, right, to literally remote control my robot. And I wouldn't go out, I wouldn't go out to my Amazon machine. I would do it just locally, like here, right? And again, the response is like, it's instantaneous. So it's a noticeable difference. And so that's why I kind of decided to spend time in this direction instead of the Amazon one. But again, even for what we're talking about, for at least for the use case of interactive control, it's doable. There's room for improvement. That someone with the right amount of web technologies background can easily fix the issue of having to reconnect every time with every request that goes out. That's just a minor thing that just goes beyond my web technologies skills. And so this could be useful. One thing I ran into, and I don't know how relevant this would be for our use case here, but as I'm driving this thing around, I'm on the second floor in my house, in the office, in a long hallway, a corner, another corner, other rooms. Pretty quickly, I get to a point where I don't get a good enough Wi-Fi signal anymore. And more than going out to Amazon and coming back and the delay that introduces, once the Wi-Fi signal goes below a certain point, things just start to really freeze up. I get ping times if I just do a ping test. When I'm sitting here in the office, my ping time is like a millisecond and a half. Okay, like nothing. Once I get out there around the corner in my hallway, now all of a sudden you get into the tens of milliseconds with occasional complete blackouts, right? And then you get into 100 milliseconds, and then obviously everything starts falling apart, right? Now you can't get the video, or in terms of usable bandwidth, when I'm sitting here and just use a utility like iPerf to measure how much data I can pump out the Pi, I'm getting around 60 megabits per second, right? Almost my full Wi-Fi capable. I'm right next to the access point. Down the hall, very quickly, this starts dropping down to a usable bandwidth of 3 megabits per second. Okay, it drops off rapidly. You go through a couple walls, and you're just not dead in the water yet with Wi-Fi, but you're just barely making it. You're just barely making it. And so on a number of occasions, I just kind of lost control of the robot, right? And I'm just lucky that I haven't gone down the stairs yet with it. So that's just something to think about. And actually a number of years back in the days of the first generation Pi, or maybe the second, when I did a round of this kind of thing with video and streaming, I remember I bought a number of different Wi-Fi adapters. Pis didn't have built-in Wi-Fi back then, right? I bought a number of different Wi-Fi USB adapters with external antenna, and so I still had some of those. And I tried, and it seems to be picking up more networks in the neighborhoods, but I'm not really getting a tangible improvement with, at least with this one, which is not the latest. This is, I don't even know what's inside of this one in terms of chipset, but it had an external antenna, and I'm not really getting noticeable better performance compared to what's built into the Pi 4, which doesn't have an external antenna. So I'm thinking I got to get myself something that has an external antenna, or do something to the Wi-Fi in my house, because the Wi-Fi in my house is not ideal the way it's set up. So and it becomes a practical issue, right? I'm trying to test sort of this kind of thing, but the moment I'm outside my office door and go around one corner, I run into issues that have nothing to do with what I'm trying to really exercise, right? I just run into plain old Wi-Fi, signal strength issues that, just get in the way of me trying this the way I want.
Hey, Chris.
Yeah.
I was just wondering, you have more, well, someone in this group will have more experience with me, but I've been looking into those LoRa radios that you can get, but I don't think that the bandwidth, like the message bandwidth on those is enough for anything like this, is it?
Yeah,
It's like
Yeah.
small messages at low bandwidth, right?
yeah.
Hmm.
So Chris,
Video. Hey, Chris, I wanted to ask, have you ever heard of the ESP32 cam? It's
Yes.
or seen it maybe?
Yeah, I don't think I have one. No, I don't have one, but I've seen it. I've seen YouTube videos. Yeah, I haven't tried it. I don't know how good the Wi-Fi is on those devices. Yeah, I have no idea.
so
Yeah.
Chris, go ahead, Ray.
Oh, the other thing, are you when you said you were going through the internet, not AWS?
Well, I
I'm
was
assuming you're
going through. Okay, just to clarify, I was going through a virtual machine that's sitting in Amazon, right? In one of the Amazon AWS services is called EC2, Elastic Compute Cloud, EC2. And so I was using that service, but it's really just what you get is think of it as bare bones web hosting. They just give you a bare machine. You decide what you want to install on it. Ubuntu, Red Hat, you pick it, right? And then you got a bare machine. You can lock it down as much as you want, open it up as much as you want. You can do with it whatever you want, right? Which is kind of what I like. And so I just need that machine in the internet so that, again, if you were to connect to that address that I just put there,
Yeah.
you would actually wind up on my Pi. The only other way to achieve the same end result is for me to open a port in my firewall and then give you the IP address to my Comcast router. It would achieve the same thing, but it's not something I would want to do.
Right, because it's not secure, right?
It's less secure. I mean, again, it's not that it's inherently insecure, but it's definitely less secure because the way I'm doing it now, it's up to me to dial out, right? To connect out. Well, let me, So the moment I'm done here and close my SSH connection, you can't intrude in my network anymore. I mean, no matter what, right? It's just so that way it's all kind of more like one-way communication. I decide when I want this to be active, and then when I'm done, it's done. There's nothing you can do.
Oh, okay.
I have comments on a couple degrees here. So the first one is with respect to Wi-Fi. So David and I, we've been fighting Wi-Fi for quite a while in one form or another. And I especially fought it because the one line follower I did, the vision and main logic was on a laptop, and the robot itself was just an actuator and a sensor. So for that robot, it took some years, but I finally figured it out a lot of what was going on. I thought because the makerspace we go to, Dallas Makerspace, was so congested, I thought, well, the best approach would be to go spend $130 on a nice MIMO, Asus Black Knight router kind of thing. And it seemed to work great at my house. So I'd go pick it up. I had a spare one. I'd carry it to the makerspace. I'd set it down. Video would drop out. Tens and hundreds of milliseconds delay in simple posts for motor commands. So I thought, okay, well, boy, it must be really terrible here. So what I do is get this little dongle like this, right? I plugged in a Raspberry Pi, just like you have, Chris. It's the Wi-Fi access point with a big gain antenna. So that was in the Pi, and this was on the floor. And at one point, one of the contests, I had this on a cable. I had my laptop on a cable to this, and I would move this to be within a couple of feet of my robot. And that's the only way they could make it without stopping after 5 feet, which it did after 6 or 8 feet. Okay, so then came the story where we went to a DPRG show and tell at the Fort Worth Science Museum. And for as bad as the Dallas Makerspace is for Wi-Fi, that place is, just forget it. Just forget it. I mean, you're better off with like tin cans and a string between them. So I had this thing, and I think, Ray, were you there? You and I were there because we were trying to demo this. And after an hour or two, it was clear that this wasn't working. I said, well, we're going to be here for 5 hours. I got nothing better to do. Why don't I pull out my $25 TP-Link access point? So I took this $130 one, set it to the dual band, right? I was on 5 gigahertz. I set that aside. I got out my little cheapy TP-Link, 2.4 gigahertz. It ran out of battery 4 hours later. It didn't drop once. It didn't drop once. So there's something about, they're just crappy. And then we noticed that we were having bad Wi-Fi in the other parts of our house. So I trashed this, and it was a fair investment, but I went to the Ubiquity Unify network, and those things rock. I mean, I can sit here now many feet from either of the access points and get like 800 megabits down over Wi-Fi.
Carl, hold that thing up again, the Wi-Fi router. See, the thing about that is it's goofy looking. That's the problem. It won't work.
Okay. Anyhow, so my point is that it might not be just the dongle or the firmware in the robot. It might actually be the router. And okay, so that's where I come in. I can share more info for anybody that's interested, but I got to tell you, as painful as to learn.
Before you go to the next step, one clarification on the piece you just finished, and it gets back to Chris said when he was talking about his router, and he could open up a port, but he didn't want to do that. You don't want to do that because when you go to Makerspace, you can't do that. You need to use the other methodology.
Exactly. Good point. I mean, I can do whatever I want in my house, actually. Assuming, actually, I don't know, to be honest, how much control I have on my Xfinity router. I'm assuming I can do it. Never tried, but I probably can. They probably let me. But being Comcast, I mean, they might not even let me do that. But you're right. If you go anywhere else, that option is off the table.
Right. So stick with the one that works everywhere. Back to you, Carl.
Cool. Hey, no worries. No, because that was a perfect segue to what I was going to highlight anyhow. Because there is a way, by the way. Okay, so with this is a diagram. At least I think of it this way, as a conceptual kind of level thing. And like with the robot down here, and my mouse is showing, and the person trying to drive it across the internet on top. So it's the stuff in the middle that we're talking about. And I think what we've just as a segue from Doug, what you and Chris were just saying, the trouble is all about how do you get this person, this human being out there, to connect with the robot with some arbitrary stretches of internet in between, right? So the way and what Chris has done is an example of what I'd like to generalize a little bit. And the generalization to me is that this server bit in the middle, one of its main functions is that a robot, wherever it is on the internet, knows how to go out and find the server and log in. And a human, no matter where they are on the internet, knows how to find the server and log in. And then the server knows how to connect them. So to me, that's a key function of the server piece in the middle, is that it basically it's like a directory service. It lets a robot find a human and a human find a robot. So with that piecing, with that thinking in mind, so then there's another 2 branches. So the first is that the one way that, like what Chris has been showing, is that he would have his robot shell in or SSH into the server, and in his browsers, his user browsers SSH into the server, and then SSH performs that kind of bridging function. But that's still just like a peer-to-peer. So there's actually another way to do it where there's a service called NG-Rock. We use it all the time at work. I've been tempted to get a license for myself, but I haven't spent enough time to do it. But basically with NG-Rock, what you can have, you put a small client down here on the robot, and then you kind of reserve a domain name with NG-Rock kind of in the middle, and then you can go to from anywhere in the internet you can use NG-Rock, and it'll route you to your Pi wherever it is. So that can be a handy service, but I don't recommend that for our project. For our project, what I recommend is that if you have, it's hard to beat a serverless instance for free or a cheap VM or something like that on AWS. But if that's the piece that knows how to let robots log in and humans log in and bridge them, then it seems to me that piece can just be as simple as possible bridging kind of a back end. And then the client UI, sure, you can do it in WordPress. You can start off by using one of these developer tools like I use every day for hitting endpoints, and let that be your UI. Or you can use something like React if you want to write a web page, or even Node-RED has a really nice dashboard with drag and drop GUIs. So you can run a Node-RED server on your laptop or in the cloud, and then let that Node-RED or whatever the Node-RED instance hit the server in the cloud. So anyhow, I just wanted to share the idea that if we can break it down to these functions, like let this piece be the bridge that where robots and people can find each other, and then have the UI be like the web server or the piece that makes some pretty dashboard with controls and knobs and displays. If we can think of these two things separately, I think it'll help us like break the problem down basically. And when I first proposed this in January, that's what I had in mind with this diagram, was that this would just be a dumb API backend, and then this could be anything, web server, developer tool, whatever. Okay. So anyhow, I want to share that. So, and then there's actually another thing for people that were on the call, but any questions or thoughts?
Well, I had a question for Chris. I totally agree with what you're saying. So I'm going to hold my question till what you're talking about is done.
Okay.
Go ahead.
Well, yeah, so why don't you follow through with that, and I'll come back to my other thing.
Well, Chris had said that he had spun up a really small web host on his VM. What is that web host actually running? I mean, did you load a piece
Ubuntu, it's running Ubuntu 16.04, x86 Linux. So it's a bit outdated by today's standards. But
is it hosting a web page? Is it hosting a service?
It's
doing?
think of it as it's a computer that's sitting out there in the data center. And I don't know to what extent it's shared hardware, dedicated hardware. I mean, the little ones that I usually use are probably shared hardware, but you're not really aware of it because it's like a virtual machine, you know, at the end of the day. And so whatever magic they do to utilize their resources, right? That's what Amazon does to maximize their investment in all the, you know, server racks that they have. And so it's just think of it, you own either a full computer in some instances or a slice of a computer there, but you have kind of full low-level access to it. And I think that's one of the key differences to that's web hosting. You can run Windows, you pay a little more for that because there's licensing involved. You can run your favorite flavor of Linux. Those are the choices. I mean, and it's just a computer that I own and control. It just happens to sit on the internet. It's not sitting in my house. It's just sitting somewhere on the East Coast. In my case, you choose where you want, what data center you want to use. You have some control over that. but think of it as a computer. It's similar to web hosting, except different sets of bells and whistles that come with it. You know.
Yes. So what I was
It-
trying to connect was, how did your client, when it talked to that server, its information get routed to your robot? Was it strictly from the port forwarding that it created with the SSH, or did you load some sort of client on the web host?
So there is something running on the Amazon machine, and that's the SSH server, right? That's what's doing the magic. So it's a function that's built into the SSH server, which is running in the cloud, and the SSH client, which is running on my Pi. So it's a feature that's built into SSH. Again, most people don't use it and may not even know about it, but this sort of port forwarding is a standard SSH feature. It's you know, nothing magic. It's built into SSH. It allows you to do that sort of thing, because when I tell the SSH to do that, the SSH server that's running in the cloud, right, is then basically saying, all right, okay, fine. You told me to listen on port 8080. I'll go do that. And it'll start accepting connections from my web browser. And through that SSH terminal connection, or kind of in a parallel channel, so to speak, obviously not in the terminal, but behind the scenes, this forwarding happens. And when you connect to port 8080 on Amazon, it comes out, the SSH client, which runs on the Pi, becomes the proxy, so to speak, and it starts to establish a connection with port 8080 that's also on my Pi. And that's why, you may not have noticed it, but on my terminal where stuff was scrolling by rather fast, it was kind of saying, it tells you the IP address of where the connection comes from, and it says 127.0.0.1. It's like,
Localhost.
what's that all about? Well, that's because when I go through the internet, from the perspective of my web server, the origin is the Pi itself, right?
So Chris, are you saying, if I understood right, is your robot the thing that serves the HTML, or do you load the HTML?
Romy, it's all, everything. There's nothing running on my Amazon instance except for the SSH server, period.
Yeah. So Doug, to answer your question about where the web host server is, the web host server is his robot.
Right. And the Amazon cloud activity, it needed to be able to run SSH, which is a relatively low level thing. I was wondering because, I have websites. And so if my website would allow me in the hosting environment to run SSH, it could do the same thing.
Yeah, that's another thing, Doug. What I was talking about before with in-motion hosting is what's available readily within the cPanel instance is a whole host of tools, okay? And one of those that's in the advanced section is specifically SSH communication. So theoretically, at least that part of what's provided with AWS could be replicated with a with a shared hosting environment such as in motion hosting.
Right. But I mean, I think I have to emphasize that this is beyond proof of concept, right? I mean, this isn't sort of kind of serving all the needs and use cases, right? Because there's no authentication taking place. I mean, this ng-rock technology looks very promising, but it except for very basic stuff, it's not free. So I don't know how well it would work, but we need something that performs the same function, but in a slightly different way, because this is very useful for a little demo and a sort of a little proof of concept work, but it's not. I don't think it's sufficient sort of for production.
A final product, but
it's good for one-on-one, not many to many.
Right, but most telepresence is one-on-one, and it's not like you're trying to hold a Zoom conference over your telepresence robot. But what you need is the ability to put authentication in front of it, so not everybody can get to that connection. So there needs to be something running on the server that says, oh, I got this thing from the client and I've got a robot that says I'm ready to do something. Let me put these two together because they both authenticated.
I
And
mean,
that's,
technically, you could do that on the robot too, right? I mean, there's nothing saying it has to happen on that middleman, and again, it's probably better there because you have more bandwidth there, more compute power.
you don't have 50
But
people.
I'm just saying, technically, it doesn't need to be at that place. I mean, the way it is right now in this proof of concept, it'll happily accept multiple connections. And several of you can look at the video at the same time. It's more the control of the robot part that's not designed for multi-user right now. And sort of things get a little out of hand there in multiple instances trying to do I²C and so on. But again, technically it's multi-user capable right now, but yeah, no authentication.
Yeah,
I
so
guess,
the authentication could just be that nobody gets the connection data to your robot unless they've authenticated on the server. And then the server will say, okay, here's your connection credentials. Go
Yeah.
connect to this.
I mean, the web page right now, I mean, there's nothing stopping me from adding some login to the web page. Now, for some reason that I don't understand, that video connection is going actually to, there's a separate socket connection for video.
Right.
I don't know why it has to be that way. I don't know enough, but that means that's kind of a separate raw connection that wouldn't be authenticated, even if my web page itself had a login mechanism, right? There would still be this other
They're both on the
socket
same page.
accepting connections that I wouldn't know how to prevent someone to connect there. So for some odd reason, this is all going over separate sockets, which is, not really ideal.
Did you have your
Right.
hand up for a reason, Carl?
Oh, no, I was saying goodbye to Ian, but I think that the separate socket is so that it can handle the lower latency and jitter.
Right.
Yeah, I think
Does it-
whoever put this together, this Pi camera streaming demo, again, maybe that was the easiest way to do it. I don't know enough about WebSockets
Yeah.
to know if it all can be done on the same port, right? And have another mechanism like a different URL to say, okay, well, this is my WebSocket traffic, this is other traffic. I think that's possible, right? I'm just guessing this was the easier route to take for the person who implemented this.
Oh, we
But
scared
back
Doug
to
away.
your card. So we kind of took a
Okay. Hey, it naturally fell into something that 4 or 5 of us are interested in chatting about, I think. So, but with that in mind, I didn't have anything else to share on the Tele API discussion unless
so
somebody
you said
wanted a
the
brief
NG
recap
rock.
of what the.
You were saying the NG rock is not what you would recommend, but it would be something that performs this middleman kind of function, right? Much like the SSH tunnel. I think this NG rock thing is doing exactly that in just a different way, right?
Yeah. So the way I view it, like let's say I have my robot and I log it into my Wi-Fi. So the Wi-Fi router, the DNS, might give it an IP address of .3 today. And I turn my robot off and I come back tomorrow and I reattach, and the router might come back and say, okay, your IP address is .7 today. So if that IP address moves around within the local network, then it's hard to know where it is, right? So,
But within the local
like,
network, the IP address is irrelevant anyway because nobody gets to your local network, right?
so unless, right, because if I wanted to, let's say I wanted to expose my robot to the world so that anybody could log into my robot, right? Because I was so confident I could keep the bad people out, let the good people in, right? So if I was going to do that, the one way would be to I could go and I could like have the router always assign a fixed IP to my, or to my robot, and then I could open a hole in my firewall for that MAC address, and I could let incoming traffic on a certain port to my house always get routed to that robot. But as long as the IP address in the house or the robot move around, then outside world can't find the robot, right? Because they. So what NGRock would do is, if I put the NGRock client on my robot, then I can, within the NGRock console, I can rent a domain name or a path, and says Carl Lott's house, robot 1. I could say this client, any traffic that comes into NGRock, Carl's house, robot 1, always route that traffic to this robot. And then whether that robot is here at my house, or whether it's at the Dallas Makerspace or the Fort Worth Science and Museum, what happens is the robot attaches to Wi-Fi, the NGRock client on the robot goes and logs into the NGRock server, and the NGRock server says, oh, Carl Lott robot 1 is now here. So any traffic that comes into NGRock Carl Lott robot 1, I'm going to route it to that robot.
Okay.
So that's what NGRock does. And like I say, my developers at the day job use it every day, because what they'll do is they run an instance of our backend server that handles call processing. They run it on their Macintosh at their house. And whenever we have to make test phone calls, we have to be able to tell the telephony company how to find our backend server. Well, the backend server keeps getting a different IP address every time when they run it in test mode, right? So they go into NGRock and they get a temporary, because in the free level you can do this all day long. It just doesn't last more than a few hours. So they'll get an NGRock address. We'll go tell that to our telephony company, and then I can place a phone call to the public phone network, and our phone company reaches out to their laptop at their house and tests the new backend, so they can step through the backend code for call processing using NGRock. It's really handy. And Ron Dagdag, a friend of Harold and I, some of you may know him, but he has this gumball machine, that demo that he did, IoT thing. So it's a little gumball with a little SP32 or something, Raspberry Pi, and he has it hooked up with NGRock so that his kids can go to a web page on their phone and put in a virtual quarter, and then his server in the cloud on Azure or something will reach out to his gumball machine using NGRock and dispense a gumball. So it's a convoluted way to like turn a knob and get a gumball, but it is an effective use of NGRock.
All right, I think I get the idea.
Okay, so Carl, why do you say that for this instance, though, or for what we're trying to do, that NGRock is not appropriate? I'm still missing. Why do you say that? Why are you recommending
Okay,
that?
so again, the way I think of well, okay, so for one reason is that it has a cost. It's like $6 or $10 a month to
Okay.
just to find that directory for your URL. So yeah, we could do that, but then I think we'd need to have, I don't know how many subs you can have for that $6 or $10. That might only route you to the message traffic to, I don't know, 3 or 5 different robots, right? So maybe that would be a simple way to do it. But then you would have to, as one of the requirements. So when we talk about what the API means in practice, what it would mean is that the robot down here, somewhere in a robot that anyone could build, that robot would have to be, you would have to go install the NGRock client on the robot, and it's lightweight. I mean, it runs on a Pi, and I don't know if it runs on Arduino or other things, but it's a lightweight client. And then for everybody that uses it, they would have to have the credentials to be able to log in for their robot. So now we have like would have to have someone, club or somebody, paying $10 a month for the URL, the domain name reservation, And then we would have to somehow on the side manage robot client side login, basically. So yeah, maybe that is a way to think about it. And you can test it out for free if somebody was ambitious. It's NGRock is, I think, straightforward to use. I haven't personally done it, but I've seen people use it. So, but the way I was thinking of it, Don, I had a different kind of concept in mind. That I thought it could be all free, kind of like the AWS one, and basically the concept was, let's see, is it sharing? Yeah, the concept was that the client-side robot requirement would be as lightweight as possible using free stuff. So you could get libraries for the Pi and SB and such that have really tiny, lightweight web servers that respond to HTTP commands. So I was thinking from architectural standpoint that the robot would be able to accept HTTP posts, basically. And then it would also be able to do posts itself so that it could go and log into a server instance. And I was thinking a server instance could be one of these serverless things, which again, if all it's doing is passing a few dozen messages an hour for a robot, or even a minute, you're not going to hit the limit on a serverless instance very easily. And if you did, it would be as cheap as Chris is talking about, a couple bucks a month, less than 5 or 10. And then that thing then that serverless thing in the middle could be the web-facing point of view for the robot. So then, as long as we had, again, some kind of server on the server, some code on the serverless that knew how to accept puts and gets, posts and gets, then any old client, again, free, like Node.js or Node-RED is free, or the Postman client is free. So you could have any old client send a post or a get to this thing in the middle, and then it could get that over to the robot. So that's where I was thinking that the kind of like for me the key if we keep the server as the kind of key thing in the middle, then the client just becomes any old client, and the robot becomes pretty lightweight, any old robot, with the smarts to connect them being that's kind of the thought, is that the smarts to connect the things would be maintained on the server, where it would be in the cloud, and where it could be, at least for a long time, I think, free, and where it could be scaled relatively easily. So I don't think NGRock would scale very well. But I think if you wanted to add more users or more robots with the right architecture in a serverless instance, I think you could make it so that it could scale with the bat of an eye.
Okay.
I think I kind of get the picture for the, command and control portion here. But what about video in that setup? How would that work?
Well, so again, this is where I was thinking that in the same way that it sounds like the solution you did, Chris, has two paths, and that's precisely why I have the two paths here, because if you to try and do video well, wow, that's really screwing up, isn't it?
Yeah.
That great Wi-Fi throughput you're talking about really going down.
I think that has more to do with my 5-monitor setup right now. Okay, so the two paths, right? So that's where I see this one path is more for command and control, and then this other path on the right is for media. In the media, since it's hard to do video, low latency, low jitter, especially with good audio, that's where I was thinking that if we just took that off the shelf, then I mean that I was cheating by copying some other solution, right? Rather than so focus on this one is what I was thinking. So then,
Well,
if
you're saying literally have a cell phone on the robot?
Yeah, yeah, just put a tripod on the robot and let it worry about the video and the audio.
Just have to have somebody turn it on or connect it.
Yeah. Oh, well, they're gonna have to turn on the robot or connect it anyhow.
Right.
Well,
And that,
why couldn't you use the cell phone to also do your command and control?
How is the question?
Do you mean for visualizing what the robot sees or for passing the command and control commands?
Passing the command and control commands using the whatever they call the USB connection on a phone.
yeah, with Android phones, you can do things. Yeah.
And Kareem's kids do that day in and day out. And sure, that's a totally viable option. Personally, I was thinking though that that then starts to have implications for, okay, well, is it Android? Is it Android Lollipop or the newer ones? Do you have to go set up the Android SDK and compile for Android? So how do you get the client on the mobile phone to do that? That's where I was going to leave it to Kareem's team and stick with what I knew, which was and what I think a lot of us have under our belt, which is Raspberry Pis and SPs and Arduinos.
Yeah. And this mobile device, phone or tablet, I guess, you're thinking that would also be connected to whatever Wi-Fi networks available, or it would have 4G?
Whatever. I mean, it wouldn't really matter, right? Because it's a totally separate path.
Hmm.
If this is some web browser, it's on the internet. So does it really care?
You know, anything 4G obviously costs money, but yeah, I mean, so if it's someone's, yeah, so I guess that would be a personal choice. If someone wanted to build a setup that could spring for a data plan, or they could just use an old secondhand, phone that's sitting around, not doing anything useful, and you could just
I mean, you could get like I got this one for $50 from Freedom Pop. It's an ancient Android phone, but it'll do the whatever and on Wi-Fi. I mean, you can just go get an unlocked Android phone off of eBay or something for $40-50, or you borrow it, get somebody in the meeting to loan you their phone and bolt it to the robot. Anyhow, maybe I got spoiled by working at Nokia for 10 years and having to carry around way too many phones, prototypes and stuff. But it seems like
I'll make one suggestion right now, because right there I'm hearing something that's the problem that's typical, and that is getting the horse behind the cart thing. I think you're all jumping way too far ahead. Concentrate on the current and deal with that future NISREIT. Okay. Even though it's good points to bring up some of what you're doing right now, but I think you're all jumping a little too far ahead. So I would say read back a little. Let's concentrate on getting the basic commands. One thought I have indirectly, I'll ask this question, is could you have the Raspberry send a single video type thing, or have two Raspberries? In other words, have two paths going effectively?
sure. What's to stop you?
Right. So that would be the thing I would be thinking along that lines.
Yeah.
But I think that's NESREIT's discussions, the
Well,
video aspect.
John, to your point, I think although we didn't get the invite to you in time for last Thursday, I think you were there in spirit, because we spent a fair bit of the time talking about just that, the horse before the cart before the horse. And then for those that didn't see the notes, so like it was basically Donna, John, Doug, and I who talked for a while. Kind of short notice, my bad, sorry. But we wound up with this action, and that was so that we could kind of have something in our hands and maybe catch up with Chris, who's been racing ahead.
Yes.
We set a target of by the 25th of March, so 3 weeks roughly. We were going to try and do at least part one, hopefully also part two on the AWS example, and then map that to our own robots. So, and then, instead of having abstract talk, we could help each other get this up and running, and we could see what Chris has been doing, and then think about what it means for the project how do we generalize it? What would we do? And then another topic was, I think, Chris, you had raised this, was on how do we share design documents, since email, well, we could use fax. I wanted to propose fax, but okay, I got a smile from Murray, but okay, so anyhow, the other target we had for the 25th was that we would each go in and look at kind of options. We defer any decisions for at least the next 3 weeks, but we'd go look at things like using the wiki function in GitHub, maybe Office 365, some shared OneDrive somewhere in Google Drive.
Carl, didn't you create, at least I thought I saw, don't we have a spot on the GitHub, Ricky, somewhere or another?
Well, there is a GitHub, but Chris said the wiki wasn't enabled, and if so, that's probably my bad. So I need to go look at that.
Okay, because I was
And I
thinking we
also
had a spot.
shared some files I think I shared some files by Google Drive. So again, I'm behind. I wanted to compile some of these emails and put them out there, and I haven't yet. But
Okay, I would suggest the GitHub and look at that a little more and expand upon that as one
yeah,
path.
that's because we got it. It's covered by the DPRG.
Right.
Yeah. So that's what we're going to do, and whatever other options we come up with. This wasn't to be
Good.
limiting, but just to say by the 25th, let's try and come up with some narrowed down ideas, and we'll make a decision, and then that's just how we'll do it for a while.
Good. And on that front, okay, I'm going to jump a little bit from one thing to another, but I do want to show one thing, and then I'll get back to that subject more direct. So let me show slide, because in the process of setting up the one or two things, I ran across this in addition to that. Went wrong button, wrong one. Where's share? Present now a window. Let's see if I can figure out which. I think, yeah. First thing I want to show was this. Okay, so this is not exactly the direct thing, but in the process of digging out something else, I saw this. So for outdoor, there's this thing, and it can haul people around. So Ray, I thought of you in the process of that. And somewhere here it tells you how the motors are 350 watt high torque motors. And that's how the inside looks. And I don't know, I haven't actually run this, so I'll see what this does, or it does anything. So yeah, so it looks like a pretty fast, big, heavy haul thing.
Yeah, John, this company Pyborg is where I get my motor controller from,
Ah,
and they
so you know about them. Oh, good.
I know about, yeah, they actually have this large one which uses I think either it uses 3 of their 55 amp motor
Yeah.
controllers, and
That
if I'm
thing.
not mistaken. But in any case, they have this model, but they've also got one that's a notch down in size, and it doesn't carry people, and it's like about 250 pounds price wise. This one's quite
Okay.
expensive, but they're well made, and I like their boards in there. And I can say from personal experience that the guys that run it,
Good.
are really helpful, and they answer questions quickly. And I either blew out a board or it was defective, and they sent one from the UK to me quickly. So it's a nice little company.
Good. But that was one thing that caught my eye. So let me now show you another thing I saw there that was interesting. So
Yeah, that
some-
motor is an older motor that they used to use on motorized bikes.
oh, maybe I closed too fast, because in the process of, anyway, on that website, amongst other things, they have a 3-wheel tilt thing. And I thought I had that window. Okay, there. It looks like I may have timeout on there.
The main page, they've got a scrolling video.
Yeah.
Oh,
And I may have, yeah, in the process, I have too many windows open. But
Yeah.
if you go to their website, they also had this tilt 3 reel type thing, which was interesting.
yeah, if you go to pyborg.org, it's got one of those scrolling videos or picture things, and it shows that.
Oh, there it is. Okay. So this was, let me go click again now that I found it. Present now, pick a board, pick a window. Yeah, there. Share. Hopefully. So, okay, so hopefully I clicked the right window because
did.
they had this thing which looked interesting. So this basically tilts. So I don't know if you've seen this or not. That was sort of an interesting concept.
Looks like
Yeah,
it
that's
makes
actually how it steers. Yeah.
Yeah, that was what caught my eye there. And then in the process, I saw the other thing too. So yeah, it steers by tilt. So it's like a motorcycle. I hadn't seen that type of concept before, so I don't know if y'all had seen that too or not, but it was sort of an interesting concept.
Well, it looks like it turns awfully sharp for just tilting. That's
Yeah.
surprising. I would think it would take forever to turn, you know?
Well,
you
they're
can
pretty
see-
small.
Okay, so and then that moves to the real thing that I was going to bring up, which was this. Because I actually have, in the process of pulling stuff out the other day,
You found one, huh?
I had this one, or well, a clone of it, I should say. So I actually, we actually want to go to number 3 because he talks about the camera on number 3. So
I like that explaining computers guy.
yeah, well, he did a good job. So
I like the haircut.
Except he's not too slow. You have to put it like on 2x speed.
so
I try not to make fun of that guy's haircut, but I just can't watch those videos.
so he goes to describe that. And and then this is how he's doing the video part. So yeah, he does strives pretty good. So I may go actually do all this because I did get a Raspberry 4, actually a 3, and in his case he said 1. So and I thought somewhere here they actually shows okay. Back up. Okay. I thought he actually showed the video. Yeah. Because he has like the video connect. Okay. Back up. Hopefully we'll get. I thought, okay, yeah, there's the camera, didn't I? No. Yeah, I'll get back. Okay. There we go. So anyway, let me run it about there. So
Has anybody in the group used one of these Devastator robots?
that's what I'm going to show you next after I get the
Okay.
video done.
Well, I've looked at these for a while. They're kind of cool. And they, they have a relatively durable platform, I think, but I don't know. So I was curious.
So here's the outdoor.
I don't know if anyone can remember, but my first experience was taking this OSEP robot tank project, and the problem I had was that as soon as I put too much weight on the robot by adding a battery, the treads fell off.
Yeah.
So you can see there's that. Okay. So let me stop this, unless you want to see more of the little outdoor, but it spins around, does things like that. So I basically have all the hardware to do that, I think, now. So let me stop this. Okay, and I will get back to my camera. So I've printed out the real top for it. Okay, and I actually got a little camera, Rev camera now. So hopefully this one works. The same lens, 5MP. And then I actually did get a 0. So because that's what he used, but I also got a 4 and a 3. So I may build a bigger platform. And then
Bought them all. Right.
and then here's the thing, which is I have had about 3 or 4 years back. So it's a variation of the same company. There was a clone version. I forget which one it is, but basically this was one that I was going to use a couple years back for our contests to get cans. So hence that's why the dripper on the front. So, and unfortunately, in his case, he didn't have it rotated, but on this, I had originally had a little ping light sensor up here that was going to tilt, but I could put the camera on this. So I don't know if there's really a benefit of having the camera move or keep it in a straight line, because it's a good thing with wire. Because in his chassis thing, he basically put the 0 here and then the camera here with a fifth thing. So yeah, I have some of the parts. So hopefully I should be able to move that along a week or 2 or less, and then I will want to talk to Tris about part of the Raspberry more. So then we can maybe duplicate what you've done at that stage. But yeah. So that's about why I've been doing this last week, and sort of the direction I've been going.
Good progress there, John. Looking good.
So yeah, but y'all might want to look at that the Pi Raspberry robot. His instructions were pretty straightforward. It looked like. Now, one thing, yes, on the kit. Let's see, what does it? This one doesn't tell me. Okay, on one of them, it tells me the type of little card came with knobs. So are you running knobs?
NOOP?
NOOPS, yes.
That's just the initial setup, right? I mean, once you're through the steps that you go through with noobs,
right?
It's called, I think, the new out-of-box setup. You end up with whatever choice you make, you end up with that version of Raspbian installed.
So which one are you running, Chris?
So most of the time, I'm using the 32-bit Raspbian. I have another SD card on which I have Ubuntu installed. 64-bit Ubuntu, actually, because that's what's needed for ROS 2. But again, I really have been mostly using just the standard Raspbian, the 32-bit. They haven't really moved yet to 64-bit. So that's what I would recommend, because that just works best with all the features of the Pi.
Right. Okay.
Chris, just to clarify, they don't call that Raspbian anymore. It's now called the Raspberry Pi OS.
You're right. Although I seem to still see the Raspbian term in all places. I don't know, but you're right. Raspberry Pi OS or Raspbian. whatever it's called, whatever the latest is, 32-bit is what most people are using.
Yeah, that's what I've been using. And there's actually, like, I'm not sure for all platforms, but at least for the Mac, there's an actual installer just for that. And you download the installer and it will install on a Raspberry Pi connected to your Mac by USB. So it's like they've tried to make it as painless as possible.
Okay. And then, well, I have no clue on this one because, as I said, I got a little collection. So here's my 3.
It's a big box.
Well, it has stuff on it like that. So it had like keyboard. So I don't know about the SD card on here. It says something SD and then a KARTE. So I don't know if that might be a language or like or what. But anyway, there's an SD card with this one too, and that's what it has for it.
And of course, the SD card would fill up most of that box, I'm sure.
It also has the power supply. A case.
I think there's a stack of 5 and a quarter inch floppy disks in there.
John,
So anyways, I have a collection. So yeah, I can play now. Now, eventually, when you saw that robot, but the problem was that was meant more for indoors. So actually, yes, unfortunately, this thing's not being made anymore either. At least it's not available offhand. But then I have this thing. Okay. Which I need to put together because, yeah, this is a couple years old. I got this for outdoors. So I figured that once get the indoor one up and running, then change over to the outdoor. But here's Israel. So, okay. So, yeah. So if you want to, and I don't know if I have the video up for this or not, but there's a video out there. I'll see if I can figure out which screen I have it on. And I'll pull this up a little bit. Because, yeah, this is meant for outdoors eventually.
So what's your next step exactly?
Well, the next step is get the Raspberry up and running on the small tank, indoor tank. This one is going to be my next goal.
Yeah, cool.
So yeah, and then yeah, whether or not I put a 0 versus a 4 on it, I haven't tried to decide which.
I saw you had the box. The big box was for the 3A plus, so I think that's the medium. That's the medium form
I have
factor.
the 3 and the 4. That's why I said I have my little collection now. So yeah. In fact, I think this is the 3 or the 4. I don't know which one offhand, but anyway, as I said, I have a collection now going. So,
well, John, having used the 0, if you don't have a lot of computing needs, it's fine. But as soon as you start adding to it, it is definitely a lower power, a lower CPU power device. It's nowhere near as fast. Like even when I SSH onto mine and let's say do an apt update or something like that, it takes a lot longer to do anything.
Well,
it's not underpowered for what it's designed for, but for a robot, I think it's a bit underpowered.
Yeah, and the only reason I have the 0 is because, well, A, the price was right. B, his video, he was using a 0, and that's where this, you know, the frame was geared for a 0. But, you know, like most things, it can be modified.
Well, they're a lovely little computer. I mean, I've got one in a nice little case and everything like that, and they're really good for what they're good for, but I wouldn't put this on any of my bigger robots. It's just too underpowered.
So yeah, that's why I said, you know, it's sort of, yeah. I was there, the price was right. So I thought, and since he had, you know, on the video the 0, I thought, well, okay, we'll go from simple and then upgrade real fast.
Yeah, that's what I'm using a 0 on this robot, for example, and it's fine. It's not a, you know, it's a very small robot. It only has 4 sensors on it, so it wasn't a problem.
Sometimes it's just fun to see what you can do.
Oh yeah, absolutely. I think it's a great little. I mean, it's a great little computer for considering the price and the size of it, and it's got a lot of features. And the 0W has Wi-Fi, you know, and it's a Linux computer, so it's pretty good. It's probably the cheapest, most accessible Linux computer that has a full GPIO bus on it. So it's, in that sense, there's not much that competes with it. I've tried to find things like things that are a lot more expensive that don't work as well. So yeah, it works really well actually for what it's designed for.
Yeah, I think even Chris's minimum little micro AWS EC2, which might not have that much more horsepower than your Zero. I think your AWS EC2 doesn't have very good GPIO, Chris.
No, I don't think it does.
So yeah, those are the toys that I managed to get, and I'll look up this Iron Man terrain because it actually was pretty interesting for outdoor. But my thought is indoor first, and then conquer at the outdoors.
Cool. You got a roadmap for you, John. We're behind you. Can't wait to see it run.
Just as a quick tip, you weren't sure if that was a Pi 3 or a Pi 4. Look at the HMDI port. If it's full size, it's a 3. If it's a teeny tiny thing, it's a 4.
Okay, so let's see. So swinging around, who hasn't had a chance?
Can I share something?
What you got?
Yeah, I want to share screen. Some
AWS part
tiny-
2? AWS part 2?
I'll follow up on that shortly, but yeah, let me share my screen and get some comments from you guys. So I don't know, can you see my a few photos here?
Is that an EC1?
What do you guys see? Oh, okay.
Yeah.
So yeah, I was using this Wixel. This is the Wixel board. I mean, so it took me a while to decide what to do, but this is what I did. So I want to get some of your comment. This is a prototype board I bought. And what I did is basically I soldered this on the Wixel already, these legs. So initially I thought I would put it on the board directly, but it's too hard. It's like I'm not sure what I'm gonna do. So I put these headers here and the other side. Oh, sorry. Yeah, this is the back side. So it's basically the Wixel. Yeah, these are the headers for the Wixel. And I had this 2 resistor. Basically, it's to reduce that TX voltage from 5 volt to 3.3 or something. So anyway, this is how I wired it. Basically, one resistor got here, the other resistor got here. I mean, okay. Tell me, guys, is this what you guys would do to use a prototype board?
Well, the only thing I would suggest is if you're going to have resistors with bare wires like that, you might want to take some. You could either cut them and put them in so they don't have bare wires exposed, or take a bit of wire insulation off of another wire and slip it onto the resistor just before you weld it down.
I see.
And
yeah.
that way you won't have exposed wires that could short out.
Yeah, kind of like a heat shrink. If I wrap it with a heat shrink tube, that would insulate it, right? Okay.
Yeah, or
Yeah,
literally just take a wire stripper and strip off a bit of insulation and just push the insulation onto the resistor wires.
I was gonna put a shipping tape, but now it's not really working, so I have to troubleshoot. But I was gonna seal this by putting a tape on top of it. Yeah,
That's how I do, John. Nice, and except I use gaffer's tape. I mean,
yeah. All right.
close enough for
then,
government work. Well, maybe not government work, but
So for the planning, I mean, I just used like a PowerPoint. I was hoping. So basically, these are the 10. Was it like 10 by 24? That's my layout of this. So I was like marking how the resistor went. I was like, it should really be like a CAD program, but it's hard to find one anyway. So yeah, I don't know. Okay, so all right, maybe I'll put some insulation on there.
there's
All
nothing
right.
wrong with that. Hey, John, question. You
You
say
know, I think, John, if you go look for like EagleCAD or Fritzig, they have a number of boards and all these kind of things laid out for you that give you connection points to do that, to do these things, and even a way to so you can route the wires however you want to route them. It's not going to do auto routing for you, but what
Yeah.
you're looking for Fitzing, I'll go look it up for you a second. I'll put it in the comments.
Yeah, maybe the one I tried, I can't even find like these 10 by 24 holes as a template to start with. I mean, I saw something that let me put resistors and everything on it, but it, it's something too fancy for me. Yeah, so some CAD tool that's easy to use. I I would like to use some CAD tool to route these around. Maybe something for prototype board. I think those are for the circuit board. Yeah, that's okay. Yeah. So the other thing, a question for Chris is, I mean, I was looking at Chris' demo just now. So I realized last week you had it as two browser window. Now it's one. So you made some changes.
Yeah, because last week the two browser windows, one was the stuff coming directly from Pololu as is. The other browser window was the video streaming demo coming from this other GitHub repo I found, and they sort of use similar technologies, right? It's all JavaScript on the web browser side, and it's all Python on the Raspberry Pi end. Wasn't exactly the same things that they were doing, but again, I had just barely enough web technology skills to just do a bunch of cut and pasting and fiddling with it, so that what you get in the web browser is a single page including the video streaming area and the remote control area, and then on the server side there's a single Python application running that I mainly took the stuff on the Python side. I just took the Python application that came from the streaming demo and added to it just enough functionality so that it could accept like the motor commands. And I was going to reach out to you actually, Murray, and I forgot to do that because you had mentioned that in Python with stuff like Flask, you can put together certain things really quickly. And the Pololu stuff is using Flask as a web server, and it's really elegant. The video streaming demo was doing it a little bit more low level, not using Flask. But I was going to ask you to point me in a direction. If you know of a GitHub repo or something where someone is doing a streaming demo and is using Flask on the web server side of things, I'd like to take a look at that just so I can see how they're doing it, because I couldn't take all of the Pololu, functionality and squeeze it into the other thing just because it's a little bit beyond my skill set. But John, to answer your question, that's just kind of what I did. I just kind of merged the two things together just enough so that it's sort of barely functioning.
I mean, when we were talking last week, what I was thinking is this is pretty close to like you have video, you can have a real-time feedback and drive something around.
Yeah, interactive, real-time control. You can add some bells and whistles to this. That's sort of what you need.
So I was thinking maybe add some buttons to make the drive a little bit easier, like this S-shaped turn, or I mean like evading something. But we took this Amazon, I don't know, the two-step tutorial because it's got instruction. I mean, that's my take. Do you have some instruction for this? What I'm thinking is basically if I follow along, I might get to know what it is, how the implementation is, and get some knowledge and make some changes.
I will put the end result of my merging of these things into a GitHub repo. I can put a couple bullet points of instructions to it, but but again, some of it, again, honestly, exactly how they're doing all this WebSocket stuff and video. I mean, there is 80% of this just is a little bit over my head, right? I can read some of this and understand what's going on and make simple changes to it, but I wouldn't be able to create something like this from scratch just because I don't know enough web technologies. But at the end of the day, most of it is straightforward. So I'll put this exact thing into GitHub, and then you can poke around with it. It is fairly straightforward to adapt it to any other robot. I mean, there's basically one piece that you have to swap out for your own piece, you know, and everything else would remain the same.
Chris,
So
what I'm thinking, I'm more interested in not in the video part because I mean the video is video. I don't think I can do anything with it. It's more the motor control part, whether I mean how that motor
okay,
control. I mean,
if that's
let's
what
say
you
if
point,
I have some
then
fancy
you
control
just go
motion, right? Yeah, if
if
I
you
have
interpret
some fancy control motion, I can click
from
a
a web
button.
page,
Yeah, yeah,
then the Pololu example, I can point you
yeah,
to their repository because that's a little cleaner and easier to understand. If
yeah.
you wanted to replicate something like that on your own robot,
Uh-huh.
that would be a good starting point for you.
Yeah.
Chris and John, actually, just to recap what I did, which seems actually over a year ago now, because I kind of abandoned it, and the reason that the code isn't on my GitHub is because I haven't used it for a long time. But at that time, I actually had both video and a web controller. So just to kind of give you an idea what that was, is I had live streaming video streaming over a port from Flask. So and that wasn't hard to set up actually, but I'll repost that. But basically, you set up a Flask server, and then you stream your video through a particular IP port, like I can't remember what number it is, and then you just point your browser at your IP address of your robot at that port, and you get streaming video. It's really, really straightforward and easy.
But was that using Motion JPEG or H.264?
I'm just using, I can't remember, but I think it's literally just Pi native. I didn't do anything at all. It was like maybe 4 lines of code. I basically just streamed what came out of the Pi camera straight to the Flask server and then hit it with my browser on my desktop. It was literally like 4 lines of code. But just to kind of go back to what John was talking about, is that at that same time, which is like over a year ago now, I had that Flask server up and I made a really quick and dirty little web page that had buttons on it. And I just had it so that when you clicked on one of the buttons, it would then trigger an event on my robot. And I actually did have it at that time able to drive the motors. So if you clicked forward or reverse or whatever, you clicked on a button on the UI, on the web UI, and that message would go to the robot and turn on a switch or a light or control the motors. And so what I will do, if I don't forget, and if I haven't done it in a couple of days, please hit me on the mailing list, is I'll go ahead and repost the video Python class and the Flask server and the Flask server interpreter for the web thing. I had a CSS file for making it look pretty and all this stuff, but the basics are just Flask server, the video file that pipes the video to a port. It was dead easy. I admit, Chris, to find out how to do that, it took a while, but the actual implementation is easy. So.
Nice. Cool. Yeah. Well,
I'll
thanks.
try to put that
Thanks,
to the list
Harold,
next
for
days.
sharing that link. I'll look into that that editing too. Yeah. Thanks, guys. Appreciate it.
John, I got one thing that I wanted to show you though, just so you know you're on the right path. If you stop presenting for a second, I'll show you this.
Cool.
Let's see. No, I don't need, I just show it on the window. So just look at my window. This is my Wixel implementation that I'm using. I just move it from robot to robot as I'm going along. And if you look at it, you can see it's on standoffs, I think just pretty much like yours. There's 2 resistors, okay? Now, one thing that I would tell you that you have to, this particular style of prototype board is a lot easier to use than a sea of points. This one actually has 2 bus lines running down the middle with 3, each pin connection attached to 3 or 4 pins. And then it has a couple of rows of
That's right. You can solder, like each hole is for 1 wire.
Well, you see, yeah, on this one you can see there's the 2 power buses on the back. This is a piece of Velcro. That's what that is. And you can see you have pads at the top and the bottom, right in this area here, where you can make connections for your resistors and stuff. The one thing that I want to make sure you're getting right, though, because you can damage your chip, is you do realize that TX and TR on your board up here is going to be flipped with the ones that go to your computer. You understand that, right?
Yeah, like the one I connect to my Arduino, it's opposite. Like
Right,
the R
exactly.
goes-
Yeah, and so the one you have to protect is the board's RX, because it's taking the 5 volts from the TX of the Arduino.
Right. Yeah.
Okay, just
Yeah,
want to make sure you got it right, because if you do it wrong, you can damage the chip.
I verified that last time. I mean,
Okay.
now it's not working anymore, but I'll find out putting an oscilloscope out there. Last time I was able to see the signals and see
Okay,
the
all
voltage.
right. Okay, but I've used this for years, and it's very similar to what you got. I would have said if you were doing it over again, I would have suggested buying, instead of a sea of points, I would have bought one that's a little more friendly for through pin ICs. You can get proto boards in all different types and styles.
Yeah.
Yeah, that would have been my only recommendation. But you can even use something that they call strip line, which is where if you look at the board, it's a sea of points, but each row of points, or each column, depending on how you want to look at it, they are all tied together in a strip. Those are nice because then you can just cut the strip and you can route around, and it's pretty much like making your own homemade PC board. All right, so I'll get off.
Okay, very cool.
Hey,
Yeah,
I thought
right.
you were a big fan of the Wemos D1 Mini. I was thinking about that. Did you not want to use Wi-Fi to do kind of the same thing you're using the Wixels for, or?
Oh, well, no. When I do have one with Wi-Fi, but what I'm saying is generally I don't want to be connected by Wi-Fi to my robot personally. Now, I'm not making a telepresence robot either, so that's a different story, but I'm talking about just something that's roaming around on the floor or something, and I generally don't want to be connected to it with full Wi-Fi. We did do it with Donkey Car, and the Donkey Car has a browser-based interface to a joystick and camera on Raspberry Pi. So, I mean, that code could be lifted very easily if you wanted to do that. And I think we all know that it was okay. There's nothing wrong with it. It's just the lags that you occasionally get would make it a little hard to steer. You've done that, right? You know what I'm talking about.
Yeah.
So I mean, I'd rather not even, I'm not interested in driving my robot through telepresence or teleop. I'm not interested in that. I want it to be completely autonomous.
Yeah. Juan, you were a big fan of the little Wemos Mini D1 Minis, right?
I have a lot of those. And I know the Wi-Fi works, but I'm so invested in the mega 2560. I don't want to. I don't want to like. So I'm thinking at some point I might go back to the ESP chips and try if everything's still working there. It should. I think it should.
Yep.
Yeah.
But
Well, they're really supposed to be nice. My only playing with them has been little things like turn lights on and stuff like that. I haven't really used them seriously for any big projects, or especially not on my robot. But I think they're fantastic chips, especially what is it? The one that's the 32.
Oh,
you
the
get,
ESP32,
yeah, you can get like 4 cores and
yeah, it's
get
fast.
off it fast.
I think
they're-
those chips more memory and faster than the Mega chips.
Oh, way, yeah. They're not in the same league.
yeah.
So, but again, if you don't want to use the Wi-Fi portion of it, there's probably better options. I probably would go with an ARM chip. Just personal preference. There's so many choices out there. You can do whatever you want to do, But I will argue, as I see the light at the end of the tunnel getting closer and closer, you try to make a strategic decision on where you want to put your resources, and try to become knowledgeable on that particular platform. It'd be better to be knowledgeable on a platform that maybe not quite as might not be the best choice than it would be to flitter around and not really get to know how to do anything on anything. This is one of the things that, like with Murray, he's concentrating on two objectives. He's Raspberry Pi. He's concentrating on Python. So everything he does builds on those two things that he's trying to learn. So that's, I think, a really good idea, as opposed to fluttering all around, because every month new boards come out. I mean, you just can't keep up with them. I mean, I did finally get hold of a Pico, and I gave one to Ron. I said, if I give one to Ron, he'll figure it out. And so I took one over to his house. After I started looking at it, I was saying, I'm sure it's going to be real interesting. It'll be fun to see what people do with it, but there's no necessarily compelling reason to use it. It's not like this is Eureka, except for the fact that they only cost $2 at Micro Center. That might be one, if you're really cheap.
Yeah.
But
I saw that. They're
yeah,
almost giving it away.
yeah, they're giving. I mean, the only problem is they only get them like, you get a batch and they go like, and they're gone.
Yeah.
Because they're allowing you to buy up to 5 at that price.
Yeah.
So I remember I had a feeling this Mega 2560 has better support for the PIO. I think at one point some code compiles on this Mega 2560, but didn't compile. There was some errors when I was running on the ESP chip. So I mean, I think that's why I was like, I don't, I don't know why, but I'll just not worry about.
If you're using the Arduino environment, if that's what your tool that you're using, there's no doubt that the 2560 has got a lot. It's very mature, real mature. That's why you don't run into very many problems. The new chips that they're supporting, and they're supporting more. They're actually going to support the Raspberry Pi Pico eventually. And when they do that, it's not going to be as stable as the first, the Uno and the Mega. I mean, because they're not doing anything on those anymore. They're just there. So, one thing that's interesting, if you don't like that format, that big board that they have, they now have one that's about this big that you can mess with. That's kind of cool.
Which one's that, Doug?
You can get it on Banggood.
Yeah, I'm trying to, give me a second. I think I've got one up here. It's just, I don't know, it might be in res, might be in the Tice, Arduino stuff. It's about I'll get back, Murray. Go
Okay.
ahead, you guys. I'll pull one out and show it to you.
Yeah. Did you get it on Banggood, Doug? Yep, he's gone. Speaking of flittering around, I have been kind of investigating the ESP32. The one that I have has, LoRa. It's got a LoRa transceiver, excuse me, built in, and an OLED display. So it's got Bluetooth, it's got Wi-Fi, it's got LoRa, it's got an OLED. Yeah, I think it's 2-core. Each core running at 240 megahertz.
Who's the manufacturer?
Pardon me?
Who's the manufacturer of the board?
It's the ESP32 made by Expressive.
Oh, Expressive. Okay.
Yeah. Anyway, so I'm thinking of using it as a robot controller because it's got so much stuff. It's kind of neat. You can make any pin a PWM output. You can make any pin an interrupt, except there are 4 that are designated as input only, so you can't make those PWM. You can pretty much, do everything you can do with any of the Arduino stuff, but at a much, much faster rate. It's a 32-bit processor, so I don't know. I've just, for the price, it seemed pretty good. What's kind of weird, you're talking about antennas and signal strength. These 2 little boards come with it's a little short antenna, very, very small. Actually, the two that I found that worked the best were actually from an ESP32 cam board, and it's for 2.5 gigahertz Wi-Fi, and I get about 3 to 4 dBm better signal off of these. That's really made for not 915 megahertz, but 2.5 gigahertz, versus these that are, I don't know if you can see that, they have a 915 label on them for 915 megahertz. They don't work nearly as well as these ones do. So if I can back up a little. So that's the antenna. So anyway, that's what I've been frittering around with.
Okay, John. This is a mega board.
Right. You got it on Banggood, right?
I think I don't know, eBay or someplace
Or
like
Amazon,
that.
or
Or someplace cheap, because I wasn't sure I was going to like it, and so it's really I always wondered. I said, man, the reason I like megas over Unos especially when I'm teaching people, is because of the 3 serial ports. I mean, the rest of it to me is a wash. You do have more memory. That sometimes comes into play, but the size of that big mega board, I guess you can take a look at the difference between the mega and this is pretty big. So
You mean it's exactly behave like a Mega 2560?
yeah, it is. It's the same chip.
It's based on the same.
Now the pinouts, the pins are a lot closer together and double rowed, but so you'd have to figure out how you were going to wire it up. But it's essentially it's the same thing.
Yeah. Not compatible with any Arduino shield, so you're not going to be able
No, you're not going to be able to. Well, you could, but not as a shield. You can put it in. Then let's see if I can get this open. If you wanted to go the other way, this little booger right here, that is essentially Uno.
Oh.
You know, I don't think it's obviously it's not pinned out all possible pins. This was made mainly for people who are making like clothes and stuff, and they want to embed a chip. So this is a little, that's from DFW. That's kind of cool. But anyway, there's a lot out there, I guess.
Doug, are you getting into cosplay or what?
Huh?
You know, wearable processors. I wondered if you were getting into cosplay or something there.
Oh, no. I'd love to do something like that just because of the hell of it. But if you watch those people who do that, man, that's harder than making robots. I mean, that's crazy, man.
And it can be really embarrassing too if you're in a little pink bunny suit.
Yeah, that's right. You gotta pick your superhero very carefully.
Yeah.
We'll know we're in trouble when Doug shows up on the web call as a furry.
Or purple, one of those purple guys, or what from what was Avatar? You know, then you'll know something's wrong.
Oh, that would be cool. They've got carbon fiber skeletons.
But anyway, there's a lot of that done by the people down at the Dallas Makerspace. And and it's kind of interesting because you like you said, you've got to be able to put, because when they get dressed, especially some of the girls, when some of the costumes they're wearing, you know, you can't be shy. Let me put it that way. It's amazing how they can make themselves look so different. You wouldn't even know it's the same person. It is truly amazing. Anyway, so
yeah, I think Christine even spent money. They look like they were full eyeball contacts. So pretty much, she had these, I don't know, non-human looking eyeballs, and it was the whole eyeball though. So
yeah.
Cool.
But she had a good costume.
Yeah, I've got. I had some issues with my laser cutter, mainly software, and I got them straightened out. So I have a design. So I'm going to be building the superstructure on my little experimental robot over here next. So I'll be adding displays and probably the IMU deck, but I'm still trying to figure out how I want to do the LiDAR on the front. I don't want 360. I might have to accept a 360 go, but I only interested in the front part, you know, the first 120 degrees. So we'll see how that goes. But next week I probably can show off a little bit of the superstructure.
Cool.
Well, I can give a brief progress report. I think I posted a message into the mailing list about it, that, you know, the conversation we've been having about PID controllers and clocks and all that. And as I wrote in my message into the forum, after David had suggested I look into the hardware clocks on the Raspberry Pi, it turns out that 2 of them are being used, but 2 of them, so far as I can tell, are free. And so I went ahead and if you go look at the message in the mailing list, you effectively go through this little rigmarole of writing to files, and you write a 1 to a file, and all of a sudden it creates a directory, populates the directory with configuration files, and then you have a period and a duty cycle file that you write numbers to in nanoseconds. And then there's an enable file that just has a 1 or a 0, and you write a 1 to that, and all of a sudden you have a hardware clock, and it works. It's actually relatively straightforward. And what I'm doing right now is writing a Python class around all of that so that the very first time the robot, and by the way, when you reboot the robot, it all goes away. So you have to basically run that script one more time. See you, Pat. You have to run that script or do what you have to do every time you reboot the robot. So what I'm trying to do is have it so that when my robot first boots up, it'll check for the existence of these files and then do this. But you have to have root permissions, so you've got to do sudo on it. So there's ways around this. And anyway, without getting into any more detail, it is possible. And from what I can tell, it is completely impervious to the system load. It should be a hardware clock on the Cortex A53 or whatever is inside of a Raspberry Pi. I can't remember. But as David had suggested, treat it as a microcontroller in terms of hardware clock, and you get a clock. And so that's great. The only thing that I can't figure out how to do is that the clock shows up on one of two pins. Pin 19 is the one I'm using. But I can't figure out, I was wishing Chris hadn't left because maybe he knows this one, but I wanted to kind of grab that signal before it goes to the pin. In other words, it's going to be at a pin, but I don't want the pin. I want the event showing up in my Python code. And the only way I've been able to do this is to take the pin and wire it to another pin.
Yeah.
So that's like kind of a waste of pins.
Murray, here's what I think is going on there. You're setting a hardware clock. So essentially you're setting registers on that particular microprocessor.
Right.
And, you should be able to also, the problem is, I think it's that chip is kind of proprietary, and you might not be able to get the names of the right register. But somewhere there's going to be an interrupt that's going to be occurring. And you should be, if you knew the name of the interrupt, you could just watch for it.
Okay.
You know what I'm saying?
Yeah.
But
and in fact, there's a number of different fairly common libraries on the Pi that are kind of devoted to treating the Pi as a Pi and not as a microcontroller. And so hence in the discussions we've been having, I was not aware of a lot of this stuff because simply it never shows up in the Python code. But like this little mystery of this hardware thing where, I write a 1 to a file and all of a sudden a whole directory pops up on the Pi that I hadn't known about. And, it's kind of this whole little mystery thing happening in the background, and where that's all documented, I don't know, but I'll dig around. I mean, the worst case scenario is I just take this wire and wire it into another pin. That's not actually that hard. And I've got enough pins I can afford to do that. It's just kind of not elegant. Because I first thing I did was I put an LED on that pin and I could see it fluctuating away at 20 Hertz. That was telling me I actually got the hardware thing going. And then I stupidly tried to wire a GPIO pin to read that pin, which of course overwrote the hardware clock. It was like, oh yeah, duh. In any case, that's kind of the progress I've made. Apart from that, I have started playing with my Pico RP 2040, and they're kind of interesting. But they're just another microcontroller, really. I mean, there's nothing. In fact, Ray, you were talking about the ESP32. That's a much more interesting board to me because it's got so much on it, and there's, they're quite a lot faster. These are kind of cool, and I'll play with it, but it's kind of strangely limited, actually. I mean, they're only $4, but to spend a lot of time on a board that's essentially as limited as this one for maybe $20, I can get a really amazing board. And I've been using the little itsy bitsy M4 Express, which is a Cortex M4, and it's actually, I've been using them now for over a year. And as David was criticizing me, I don't really take advantage of it. And it's actually a really nice little board. If I'm going to play around with microcontrollers, the only thing that I've had trouble with is I don't want to use CircuitPython. I want to use MicroPython. And unfortunately, the itsy bitsy M4 does not support MicroPython. It's only CircuitPython. So I'm kind of looking around for a MicroPython board. And I think, Ray, the ESP32s do MicroPython.
I think so.
I think aren't they native Luna? I thought they were Luna natively. Well, or at least that's what the first programs came out in. But
you mean the ESP32s?
No. The ESP32s, yeah.
Yeah, because I mean, the one advantage of the RP 2040 is that it can be programmed in MicroPython. It's
Yeah.
not. It's a 2-core. I can't remember, 120 megahertz. So it's not a really slow chip or anything, and it is MicroPython capable. So I may end up using one in the end. And they come in a million form factors already. In fact, there's a itsy bitsy form factor, and there's a tiny form factor, and in fact, they're not released yet, but like the itsy bitsy form factor uses the same pinout as the itsy bitsies I'm using, so I could literally pull the one out of my robot and plug in an RP 2041, and it would be plug and play just like the itsy bitsy I've been using, and all of a sudden I'd have MicroPython. So once Adafruit releases that, I'll buy one and try it out.
Yeah, I think Adafruit even put a Wi-Fi transceiver on a board with that processor.
Yeah, because they're going to release a tiny, I think they're calling it QT. It's a tiny little board. It's about maybe, a 3/4 inch square. And that hasn't been released. They haven't released hardly any of them yet, but they've got them planned, and you can see the prototype boards on their website. So they've got an itsy bitsy, a feather, a QT, and maybe one other. And it's an exciting development to see these boards come out so quickly. And as soon as that itsy bitsy one comes out, I'll probably use it, like I said. But the fact of the matter is that I'm really looking for another MicroPython board, because CircuitPython is just too limiting.
Yeah.
Well, these Picos run on MicroPython. That's their preferred language. And so, I mean, and as I understand it, it's supposed to be, a pretty complete port of Python 3.7.
Yeah, and that's all I need.
Mm-hmm. Yeah. Well, they're $2 boards. I don't know what it would take to get something over. Have you ever sent anything to the States? What does it cost to get something like that, or what's the postage?
I mean, to get something from the States?
Yeah.
I buy stuff from the UK, from the States, and from Canada all the time. I'm buying from Robot Shop, Adafruit, and Pimoroni, and those are the three companies in 3 countries. And actually, the States is usually more expensive because it's usually UPS for shipping, whereas Canada has Canada Post and the UK has British Post, and those are like considerably cheaper. So it's usually the postage. Like it's like either 7 or 9 pounds for the British Post, no matter almost how big it is, until you get to a big package. And Canada Post, I think, is like $6 Canadian, so it's not that expensive. Where it's like $25 UPS. Yeah, I think it just. Go ahead, Doug.
Yeah, I was going to say, like, one of the things that keeps me going to RoboShop as opposed to DF Robot, because I like DF Robot, is postage. I mean, it's like they actually have very good prices. You go in, because it's their boards, you're buying them from the guy that made them. So you go ahead and, you get yourself an order, and it costs almost as much to ship it to you as it does to buy. And it's very off-putting, especially if any of them show up on Amazon for $1 more. I just.
Yeah. Well, yeah, being in New Zealand, the shipping does come into it quite quickly.
Yeah.
And so far I've been buying mostly from Canada or the UK just because of the shipping. But then that whole thing with Pimoroni is that they're doing that pound for dollar thing, where it might be $4 in the US and £4 for the same item. So I have to kind of balance that,
Yeah. I've noticed that too on some of the things that I've had to buy from the UK. And the pound and the dollar, whatever the number is, it's the same.
Yeah, bizarrely.
Not that they're equal, but that they're the same. You know what I mean?
Yeah.
So it's 50% more all the time.
Yeah. And Pimoroni, I like their stuff, as you all probably know. I've been buying lots of their boards, and their breakout garden stuff is great. But I do have to balance that on cost, because it is generally twice the cost.
Yeah.
So.
Yeah. Anyway.
So I found the video, so I guess I'll show you after I get the one done. The next one after that one, which there. There. So let me fire this up. There we go. So this is the outdoor version that after I get the indoor one up and running. So it should do good outdoors. So but the key is getting the indoor one to work first.
John, is that the same robot that is sold by Pyborg?
Probably there are variations out there. This one I had gotten a couple years back. In fact, I'll go to why I said a couple years back. Let me click that one.
Yeah, because Pyborg has a four-wheeler that has big wheels and an aluminum body that looks
Right. Well, as I
very
said,
similar.
they're variation, but at least
No,
here it says this continues. I don't know how many years back I got it, but yeah. But you know, that's why I said it's a variation. And you can see basically I had, you know, 4 motors and that, and there's his specs. So yeah, key is get the indoor one up and running, and then should be able to transfer over to the outdoor one pretty easily.
It looks like that would be able to climb steps pretty easy.
I don't know if that, but it will at least do the curves on that on the street. At least the video, you know, he was running over the curves.
Yeah.
So yeah. So yeah, that's the one will be geared for the outdoor. At least that's my plan right now.
Oh, Carl, it occurs to me, did you ever get an email from a guy named Maximilian Earhart? He was the guy that had done that ExoMy little rocker bogey robot. I had been, well, go ahead.
Looks like I did.
Yeah, because what I did is I got in touch with him because I'm kind of just doing the very preliminary research on doing like a little rocker bogey robot of my own. And the ExoMy and the ExoMars robot is different from the NASA robots in that they don't use a rocker bogey. They use what's called a triple bogey, which is it's different. And basically, the rocker bogey has 2 rockers, and on the back of that rocker is another rocker, and that's what NASA uses. The triple bogey one that they use, and the ExoMars robot that's going to go to Mars uses, is 2 rockers on the side and a side-to-side rocker on the back.
Huh.
And in the communication with him, it turns out that he was on that project. He was actually a worker on the Mars project.
Yeah.
And so he sent me some of the stuff about that. And I was going to forward it to the mailing list, except that it was what he sent me. And so I thought maybe, so what I had suggested is he contact you. He's actually willing to come into one of these sessions and do a presentation. So if you get back to him, he was willing to do a presentation about the ExoMy robot to our group, which I thought would be pretty cool.
That sounds interesting.
Seems like a nice guy.
I wonder if he'll do it a monthly meeting on a Saturday.
Yeah, that'd be great. For
2 hours, yeah.
Well, I'll leave it up to you guys to work it out. But Carl, if you haven't got his email address, I think I can send it to you. I've got it right here. But he basically was on the ExoMars project, and then he was part of the ExoMy project as well, I believe. And I mean, he's a serious roboticist, and seems like a nice guy. He's in Germany, I think, and he just got off the ExoMars project about now. He said he was only on the last couple weeks of it, so he's no longer on the project. Probably because the project, I think, is closed. It's on its way to Mars, or whatever. I don't even know the schedule of that. But in any case, he seems like a really interesting guy, and he's got lots to talk about. And he was willing to defend their use of the RAWS operating system, and talk about what they've done, which I thought would be quite informative.
Yeah, that'd be cool. All right.
Yeah. Hey, thanks. I somehow missed your email, Marie, but I see it now. He has not gotten in touch with me, as far as I can tell.
Oh. Well, I'll go ahead and ping him. I'll ping him and ask him if he's still interested in that. He could. I told him about you, and I said you're the president of the club, and that you'd be welcome to just show up without an introduction.
Oh yeah, ad hoc. Nothing fancy.
But I think he'd kind of like to do a presentation, and so I think he seems like he wants to be invited. So
sounds like a monthly meeting. Sounds like a monthly meeting.
Yeah, I can send an invite to you if you wanted to forward it to him, for example.
Well, if you don't, do you have his email address?
No, I don't seem to.
Well, I'll tell you what, I'll forward the email to you privately, and then you can send him a message because he's I think he's expecting a message from you.
Oh, good. Okay, yeah, please do, and I'll reach out. Thank you very much.
Yeah, yeah.
Appreciate that.
I'm being attacked by my cat. What do you want? Yeah. Okay. Well, I just remembered that, so I thought it was good.
No, thanks very much, because so many things dropped off my radar in the last few weeks. That's awesome.
Yeah.
Cool.
So there's
Very
two
cool.
ways of doing that linkage. Okay. I've heard the one where they have, the front two wheels and then you have that big angle like thing. So there are two variations of that. Okay. So
Well,
which is better?
the part that makes the NASA style, and he said that the NASA robot, the Perseverance robot,
Right.
the reason that they continue to use the rocker bogie is, as he said, is that that's kind of the tradition at NASA. But the difficulty of that is that the actual armatures on the side are more complicated, and there's also an arm that goes between them that balances the
Right.
robot. And whereas with the triple bogey one that the ExoMars robot and the ExoMi toy robot have is considerably easier because there's no side-to-side connections. It just uses two rockers and then the back rocker, and you don't have any connections between them. But he said that in their experience, it wasn't really a problem, that it could still drive over. It still had the same level of floor clearance. And my guess is the biggest difference is that when the robot's at a big angle, the whole body of the robot would be at a bigger angle
So
than
you have
on
a
the
roller problem.
rocker bogey. But that's probably not a problem. I mean, for our robot, certainly wouldn't be. And they
Right.
didn't seem to have a problem with it. And he even sent me a paper which I couldn't get to because I'm not an academic. But there's even papers written about this difference that academics have dealt with and gone into the physics of it, of course, because there's billions of dollars at stake. But they've defended that design over the rocker bogey and felt it was just fine. So for my purposes, it's a lot easier to implement. It's just 3 pivots.
Mhm.
So
Nice. Perfect. Perfect. Got a lot going on this year. So many different directions among us.
I was actually interested in that rocker business too for an outdoor robot.
Yeah.
Well, it gets expensive fast though, because you've got the 4 steering servos and the armature to connect that to each of the motors, and you've got the bearings and the frames. And I started adding up in New Zealand dollars, and it's a $1,500 robot easily.
Yeah.
But for you guys with the disposable incomes,
As semi-retired guys with all
yeah.
Didn't you get the money printer? I mean, it's around here somewhere. Counterfeit. Okay.
I'm thinking about it. I'm going to use the same 25 millimeter motors, and there's a couple of companies that are selling, there's this whole arrangement of a servo and a frame that's got connections on it, so you can bolt things to it. So there's stuff out there, but it's not cheap. By the time you get a significantly strong enough servo that moves slow enough to do steering, and I need 3. Like the Thunderbolts I use are for 2 motors. I'll need 3 of those, and those are 37 pounds each or something like that. So you add all that stuff up, it just starts to, and I need bigger batteries, and yeah. Yep.
Yeah, those motors, those are it's just a straight DC. It's not a brushless, but
No.
In the kind of the first motorized bicycle kits, that's what they used. So that motor's been around. That design's been around for a long, long time. So,
I mean the 25 millimeter motors.
no, the one larger one in that. Oh, I thought you were talking about the larger.
No.
A huge soup can maybe sized motor.
No, I'm sticking with the same kind of basic drivetrain of the robots I've got now. The 2 that I've got use the same OSEP motors, which are the same as the Make Block and the Pololu 25 millimeter motors. And they've, the Pololu ones have got the encoders on the back of them already. Makes it easier. And I'm going to need 4 encoders, and it's.
They also have helical gears, I believe.
Yes, yeah.
as
Yeah, the
opposed to
25
just spur gears on the other ones.
Yeah, the Pololu 25 millimeters with the encoders on the back of them and they're kind of sealed units, or not sealed, but they're kind of all together in one package. And that's at this point the motors I'm looking at, because with the encoders built in, the helical gears, like you said, Doug, they're like, I can't remember, $47 a piece or something like that. They're not cheap, but
Yeah.
they're good motors.
Yeah, I don't. Well, here they're a little. Well, you know, the real trick, Murray, is next November when they go Black Friday. That's when you buy all your motors. Okay, no, really. They usually drop the prices about 40%. So
Yeah.
and Gene got them for 50%, I think, this year.
Yeah.
So
The what some three wish
Prep
list
robotics
type
may
of
be
yeah,
thing.
a little bit,
yeah.
I was really just saying, well, I would like to take it if you give me like half price, and they took it, so it was a surprise from Pololo.
Yeah.
Well, considering I need
you.
4 with encoders and 2 without, I need 6 motors and 4 encoders. That's a fair bit of hardware.
Yeah, yeah.
I thought the real trick was to go get an outdoor simulator, a robot simulator, because then the shipping it's pretty low.
disappeared.
Well, at this point, it's still Murray's dream robot. I'm not getting too seriously, but maybe by November I'll be thinking about it. But as David keeps pointing out, I keep getting ahead of myself, and I need to get a robot on the ground with its PID controllers and everything all running with a full set of normal, simple sensors, and just get that running with a subsumption architecture, and then I can start thinking about 6-wheel rovers. You know.
You're getting there.
You do know that that Dave created it's like a real-time operating system for that can be on Arduino and on ARM.
It's LMK.
What is it? It's
LMK, he calls it.
LMK?
Yeah.
Okay, but
Lightweight
anyway.
multitasker. He based it off of Steve Ciarcia, circuit seller, something or other, sometime back, and extended it. But it's a kind of a round robin time slice kind of thing.
Yeah, what do they call that? Otherwise, one task owns the system at a time, and they take turns. Okay.
Yeah, Doug, I am aware of that, and in fact, that's kind of the inspiration for what I'm trying to do. But I'm doing it, I'm basically taking the same, I guess you'd call it architecture, but implementing it very, very differently. And in fact, what I've been working on, which is boring to anybody else to hear about, is that the message bus that I had written was based on what's called Pi message bus, which is you send a message into this bus and it gets distributed out to the other subscribers to the bus. The problem is it's not asynchronous. And so if one of the subscribers takes up 5 seconds to do what it needs to do, that means the next subscriber on the bus doesn't get it till 5 seconds later.
Right.
And so it turns out I've had to write my own, and that's what I'm doing. I've got actually I'm maybe 50%, 70% of the way along on this. There's a library in Python called async.io, and it has an await and a sync or an async keywords, and it basically adds this asynchronous functionality to Python. And I'm trying to write an asynchronous message bus in Python because there, from what I can tell, isn't one that does what I need. And that will be where I send my messages in from, let's say, my sensors. And then just like David's, it'll be in a round robin loop and basically have the subsumption disable, enable on any device. So yeah, I'm heading that direction. And I have been inspired by what David did. Yeah.
Yeah. I didn't know if you knew that he had that, and that code has been released to, I think it's on our GitHub.
But I think it's C++, isn't it?
It is C++, but I don't know that it's on the GitHub yet.
But it's C. But
yeah, I think he might even have it on his website somewhere. I have seen it at some point, I think.
It's called, I think he calls it libtask, though, Carl. Libtask.
Well, yeah,
he may have renamed it, but I know when he first showed it to me, I think it was called libtask.
Well, he just rewrote all that stuff, I think, didn't he? He was saying he was moving it all.
He moved it over to ARM.
Yeah.
So he had to make some changes, but before that, he had it on all of the AVR type
Hmm.
products, and he had it on the Teensy.
Hmm.
And then, so then I've actually seen, when he first started it, I was involved with him, and I got it into, he got it into, onto the STM32 boards.
Hmm.
So anyway,
LMX. He calls it LMX. There we go.
LMX, okay.
Okay.
There's a
I
link.
hate to say, but I've got to get out of here. I've got dinner coming up pretty soon.
You got dinner and we've got
you all guys.
sleepy
See you next
time.
week.
All right, we'll see you. Anything else from anybody else?
I'm done.
I haven't
No, we're
heard
good
from
tonight.
Donna. Donna, have you gone?
Donna went.
Before you came in.
Yeah, yeah. No, I
Donna
don't
was
think I've
here.
got anything else. I'm tired too, so my brain is halfway turned off, I think. So
Okay.
Donna kicked off a marathon discussion on the telepresence thing, so looks
Yeah.
like we're
Yeah.
good.
All
All
we'll see you
right.
guys next week then.
Take care. Thanks all.
hey, thanks
Good
all.
evening. Good
Bye
day.
bye, guys.
Night,
Bye.
night.
Hi guys.